Hello? Cool. We're live, and welcome to the stream. Today is going to be a little different in regards to what we normally do, or what I normally do. And yeah, we're going to be going over a leak code question. Let me pull that up. And valid anagram 242, and we're going to be solving it. And yeah, hopefully we'll be able to get through all of this today. I just want to make a clear, FYI to everyone who is supporting me and watching. And again, thank you guys so much for all the subscribers. I was not expecting this amount in this short amount of time. This is only my 5th day, but I already have like 19, 20 subscribers already in that amount of time, which is crazy. So thank you guys so much for supporting me. Yeah, I have no words to say. Thank you. It's nice knowing that people are out there supporting me, and we're all working through this together, because this shit is hard. Yeah. Where was I going with this? Oh, sorry. Clear FYI. So the schedule is going to change in the next coming weeks, work schedule and streaming schedule wise. So I believe I'm trying to do streams like earlier in the day versus like right now at 4. So I'm gonna try to like actually create like an actual schedule. But for right now, it's Sunday through Friday. And Saturday I'm gonna take a day off, just because of like religious, reasonings, like church and whatnot. So yeah, hopefully that answers everyone's questions. I did leave a post in the community chat, as well as on my description, and in most of my descriptions. Yeah, I'm just letting everyone know that my schedule is going to. It's not every day. It's just 6 days out of the 7. So, all right, enough talking, and let's get to let's get to let's get to coding. Oh, no. Let's close the YouTube thing because I don't think that's needed right now. Oh no, we need that. Also, the reason why am currently late, or this stream is later in the day, I was trying to fix my streaming issues, like my audio, and because I want to be able to hear some audio and not some audio. So like right now, I believe I have Spotify on, and if I were to watch a video like right now, then the audio will come out. But like they were mixing all together, and I have had some copyright issues currently, so I'm trying to be able to like separate them. So yeah, just FYI for everyone. Yeah. Okay. Let's. All right. So we're going to do. 242. Valid anagram. So, sorry, I'm going to be talking and trying to do this at the same time. I believe that think that studying theory like is important, and but I think that I'm studying more than I am coding, and I think that needs to change just a little bit. So I'm gonna start trying to do more bleak code problems or just small problems that are not as difficult. And yeah, so we're gonna solve one problem daily. I'm gonna try to understand the problem thoroughly. So I'll try to spend 30 to 40 minutes trying to solve the problem. And if I'm stuck, I'm gonna go like either read or like watch some stuff and see yeah, like how to do it, then try to write the solution myself. And if I don't know how to do that, I can just go back and look at the code. And then after that, just analyze and kind of understand the the time and space complexity of the problem, understand like what data structure and algorithms were necessary for this specific type of problem, and then I can study more about this, and then yeah, I'm gonna write some notes just to help clarify everything, and yeah, um, yeah. Sorry, let's just try to get a jump into it. All right, let's look at the problem. Oop. All right, so given two strings of S and T, return true if T is an anagram of S and a false otherwise. So the example should be anagram, and then T is anagram, which is true. And then the second example is rat and car, which obviously is false because the only, yeah, A is the only thing that's. All right, constraints. S and T consist of lowercase English letters. What is the input contain Unicode? All right. Okay. Um. All right. So if I can type right, so we have the input, which I believe is S and T. We have to process this string, and basically, from what it states, we have to determine if S and T are both anagrams of each other. And then the output should be true, return true or false. Okay. Uh, I believe I need to like refreshen myself on dictionaries of Python. Because I believe that is how we are going to solve this. Mm. Okay. So yes, I was right. I was like, I know that there's like keys and values. So and key and value pair. All right. Um, okay. Mm, okay. So I'm assuming that the dictionary, if the example was, so example one, I want to use their example that they had. Um, so example one was uh, their input S was anagram, and then input T was nanogram, or example two was rat, and I believe the input T was like cars, yeah. So I'm not entirely sure what this means, constraints. 1 is less than or equal to the length, and t length is less than or equal to 5 to the 10 times 10 to the power 4. S and T consist of the lowercase English letters. I'm new to this, so what if the inputs contained Unicode codes? How could you adapt your solution to such a case? Um, hmm. Okay, so if we were to create a dictionary for this, I'm assuming that we would be able to kind of like, we would be able to break like the word itself and break it down using the dictionary. So we would need to figure out the frequency of each character. Okay, so find frequency of each character. So like for instance, rat would be, would that be like 1 or something like that? Yeah, it'd be like, but should we like, huh? I want to see. Freak. Oh no, I should move those over here. Right. Okay. Sounds like, how is this going to be possible? So, sounds like the key value pair. So, key and value. I'm assuming it would be, yeah, based off of like the character. So for instance, the rat one, so it'd be R. Be 1. Erase this. And then for car, it'd be Okay.
So we will check
The frequency. We'll check the frequency of this. And then once we do that, we're going to compare or return, because this is this is S and this is T. So then we return S if they're equal. Wait, why did I put 3? Discrete structures. And return that. And if it doesn't come, then that's okay. I'll try to code that myself. All right. So is anagram. So no, I can't use that keyword. Frequency of S, which is into frequency of T. I should code because I'm not code. I should comment. Create dictionaries. Loop through each loop through each anagram. Assign each string assign each string's character a key and value. I'm assuming that's right. Right. I want to know what self is though. And I want to print out. Oh, you guys can't see shit. Oh my god. Nope, that's the wrong one. Boy, it's my. Oh, wrong one. Bruh. I was like, can they even see this? I. Oh, I didn't put any output. So S is anagram. Okay. Is it self? Isn't self a part of classes? Do I have to assign? Hmm. Damn, I'm not familiar with that. Hmm. It's hmm. itself is a reference to the instance of a class that calls the method. It allows you to access instant variables and other methods of the class. If this code isn't meant to be part of the class, self should be omitted. Yeah, but it is, so. Mm, okay. So, all right, just. So, for char in S, right? Would it be in char in S? Yeah. And for char in T. Are we able to? Mm, I'm not understanding this logic. Just frequency. Frequency. Char. So, S. It's char. Yeah, I need to understand how that works. Oh, let's ask chat. Could you explain? frequency s dot, because I'm not getting this get char +1. All right, what it does is it checks if the character char is already a key in the dictionary frequency s. If the key exists, it retrieves the current count of the character. If the key does not exist, it assumes that the count is 0, increments the count by 1, and updates the dictionary. So, excuse me. The get method is in a dictionary retrieves the value associated with the key. If the key is not present, it returns the default value you provide, in this case, 0. After retrieving the current value of the key, we add 1 to increment the count. Finally, the incremented value is stored back in the dictionary using the key char. If the key doesn't exist before it gets created. So step-by-step process. So if the char is h, sorry, why am I saying char? Character. If the character is h, so h and 0, default value, since h is not in frequency, it's in s. Oh, okay. So then it just, so basically we're changing the value of the key value pair of this of the dictionary. So if it sees that there's another one, if this sees that there's another h, if we're using hello for this example, then it would add 2, right? So for like L, it would do it again. Okay. All right. Oop, why did I open that? All right. So frequency s dot get char 0 +1. And I'm assuming we just do again. Not x. There's already a typo. Oop. Okay. So we created the dictionary. We loop through each anagram, assign each string's character a value and a key. And then we need to return. We return the value, a Boolean value of the equivalence. I don't know. Why am I just return a Boolean value of true or false. So return frequency s is equivalent to frequency t. Nice. Can someone explain this to me? Like, I don't know what this means. Um, um, Yeah, because I don't know what constraints mean. So the length of the S and T is always will be between 1 and 500,000. Okay, this means the solution must handle strings that are larger than that. S and T consist of, yeah, yes. But there's also this. There's also this issue right here. Like, what does this mean by if the inputs contain Unicode characters, how would you adapt your solutions in such a case? I don't know what this means. Uh, Hello. What does to explain what this follow up means? I'm kind of brain dead. The follow-up question addresses a scenario where the inputs might contain characters outside the standard lowercase English alphabet. Let's. Okay, so then we just have like an edge case type of situation type of thing, or if I'm using that right. Basically, if the strings, if they're not even matching, then okay, so that's how we would. So it's like, what the fuck does that mean? Check to see if S and T. Check S and T's lengths. So if not equal to the length of T, then return false. Oop, what did I do? Hmm. Oh, duh. Forgot the. Okay, let's run it again. Nice. Let's submit it. Damn. What are people's solutions? For element in S, if element is in S count keys, increment the element by one, else. Oh. Damn. Okay. Damn. What's that? Oh no. Not a new solution. What am I doing? Okay. So now I think I should figure out like the complexities. Cause bruh, I don't know none of that shit. Okay, so yeah, we need to go over that. Cause I'm like, bruh. So the complexities. I don't even know. I think it's how you spell. Let's close that. Um, let's erase that. Okay. Um. So, so what we should do, or what people are telling me to do, is to understand the problem thoroughly. So the problem was to determine if these two strings are anagrams. All right. Okay. And I still don't know what like the constraints are. Well, they tell you what they are, but I don't. Here, let's go back. Okay, so the constraints, depth 1 is less than equal to s dot length, and t length is less than or equal to 5 times 10 to the power 4. So from what I remember is that it has to be between 1 and what's 10 times to the power 10 to the power 4? 50,000? Yeah, 50,000. Okay. And what was the other constraint? S and T consist of lowercase English letter. Consists of lowercase letter. English letters. All right. Um, so they're saying constraints. I should know that. I should. What? What are we solving? Oh, can't spell. Oop. My notes are horrible. Okay. And then the approach. Like, what is my idea to solve this problem? So to try to use a dictionary to compare key value pairs, and then I guess like determine, well, we should have done that before. Determine if character, if strings are the length, determine if the strings length are the same. Can't write for crap. Okay. All right, we solved the problem. So the process one sorts a string, compare them, and sort the character count. For similarity. Now we're going to go into complexity. am very not good at this, so I know O of 1, big O of 1 is how do I say this? I think it goes it's like a exponential type of thing, but it doesn't it just depending on the size of the size of the data set or whatever, it'll go. It's not like it is efficient depending on like the size of the thing. So, but I know O of n, bro. Actually, I'm gonna act like I know what this. I'm just going O of 1 versus O of n. Oh gosh. Imagine you have an array which stores events in the order they happened. If each event takes the same amount of space in a computer's memory, you know where that array begins and you know what number event you're interested in. Then you can pre-calculate the location of each event. Imagine you want to store records and key them by telephone numbers. Since there are many numbers, you can calculate a hash of each one. The simplest hash you might apply is to treat the telephone number like a regular number and take its modulus. Take it take it modulus the length of the array you'd like to store the number in again. Again, you can assume each record takes the same amount of space. You know the number of records, so you know where the array begins and know the offset of the event of interest. From there, you can pre-calculate the location of each event. If array items have different sizes, they instead fill the array with pointers to the actual items. Your lookup then has two stages. Find the appropriate array element and then follow it to the item in question. Much like we can use, I don't know what the fuck, Schmancy GPS system. Okay, this is too long. Free code camp. Constant. Okay, yeah, we're gonna go here. Constant time algorithms will always take same amount of time to be executed. The execution time of these algorithms is dependent on the size of the input. Like I said before, I was like, I think it depends on the size of the data set or the input. Yeah, a good example of big O of 1 is time is accessing a value with an array index. O of n, an algorithm has a linear time complexity if the time to execute the algorithm is directly proportional to the input size n. As a linear time if to execute the algorithm is directly proportional to the input size n. Therefore, the time it will take to run the algorithm will increase proportionately as the size of the n increases. A good example is finding a CD in a stack of CDs or reading a book where the n is the page of numbers. So aren't O of 1 and big O of 1 and O of n kind of similar based off of the size of the input? Because wouldn't. I'm going to ask chat. Wouldn't big O of 1 and big O of n be the same depending on the size of the data set or input? Like, when they might feel similar. If the input size is small, the actual difference between O n and O of 1 and O of n might not be noticeable. For example, checking a dictionary with 5 items for lookup feels like just as fast as summing a. Yeah. In practical terms, when n is smaller, linear operations might execute so quickly it seems instantaneous. Right. I was just like, but okay, so they are mutually depending on if things are super small, then they would kind of be similar because like what chat is saying, sometimes summing a list of 5 items together would be way it's as quick as trying to find in yeah. Okay. The difference becomes significant as the input size grows. Imagine a list of a million elements. Accessing an element is still instant because the time doesn't depend on the list size. Summing up all elements will now take considerably more time because it has to iterate through the entire list. Okay. All right. So yes, they are when they're very small, O of big O of 1 and big O of n are like they're not noticeable, like because the data set or the input is so small that it doesn't really matter. But if, like, again, if we're dealing with a million sized data set or input or whatever the fuck, it would be noticeable. So yeah. Okay. Um, since we solved the problem already, then I just need to figure out the complexity. But then I don't think. Yeah, bro. I don't know. I don't know. I need to read more because there's so many other time and space complexities. I don't really know which one it is. Fuck. Uh, yeah, we're gonna have to go back to the drawing board. I don't know. I need to read. Differences between. Uh, oh, people are chatting. Oh, nice to see y'all. Phantomical. Phantom. I don't know how to pronounce that, but hello. Hello. Yes, sir. Let's struggle together. Phanatome. Cool. Yeah, okay. Phanat. Yeah, nice. Well, nice guys for checking in. Yes, we are in the same page. And let me just show everybody what I was working on. Oh, wrong one. So, yeah, could you kind of anyone in the chat really like just kind of go over like quickly just the time and space complexities of because I know there's well actually I take that back, there's too many of them to just go over all that at once, but in regards to this question I because we have to go through the dictionary and then we have to assign like we have to go through each of them assigned a character like a character and then we have to increment that. So that's already not O of n. It's like something else completely. So yeah. Now I just need to figure out what that is. So oh. Okay. Uh, um yeah, people say that if you can't solve the problem, you're just gonna have to look it up. And I'm not about to waste time because. All right. So let's just. Mm, what is this time and space complexity of 242 valid art anagram? All right. The main. Okay. So from what they're saying, or what chat is saying, um, bruh, let's swap over to studying. So they are saying, ooh, the main operations in our solution involve iterating through S and T. We traverse both strings to count the frequency of characters. Each traversal is O of n, where n is the length of the string. Right. If we, yeah, I was right. Because, like, you have to go in there and traverse through the whole thing, which is O of n. But then I was like, from that point, I'm like, I don't know. After that, I don't know where we are. If we use dictionaries, comparing two dictionaries involves iterating over their keys and values. This takes big O of k, where k is the number of unique characters. If we use a fixed size array for English letters, the comparison is O of 1, since the array has a constant size of 26. Yeah, because of the English alphabet. Okay, so using dictionaries, the time complexity is big O of n plus k, according to chat. Using arrays, fixed size for English letters, big O of n, because the comparison step is constant time. In practice, if n is large and k is relatively small, example with lowercase English letters, the time complexity is dominated by big O of n. So for dictionaries, so the approach, if I can spell right now, time. So it is big O of n plus k, because from what they were saying, big O of n, you have to traverse through the length of the string, and then big O of k, we have to iterate over the keys and values. So then it's just big O of n plus k, and then for just in so but for fixed size arrays, like the English, gosh, I can't spell. It's O of n. Sorry, guys, you are like messaging me, and I'm just looking at it now. Okay, how about t equals length and s equals 0, t minus s plus plus if t is not equivalent to s, return false. Time and space complexity measure how much more time and how much more space you need as your input increases. Do you understand that? Yes. Sorry, array. Okay, that should make. To compare arrays, you have to iterate through the array, right? Which is right. And then O of n is technically still O of 1 if you iterate once. Right. Time complexity is relative to input. If you consider the input to be the amount of arrays, then sure, it's O of 1, but it would only work if arrays are the same size at all times. If you consider the input size to be length of the array, which is more useful, then it is O of n. It may not make sense because I'm oversimplifying it to be okay. The topic XID I don't Diego did go. Yeah, we're talking about complexities for this specific problem. And sorry, I pronounce funatomical and anime akacha. Oh, and emine akacha. They're trying to help me out. And so we're talking about just complexities. Makes sense. Thank you guys. Okay. Um uh the space complexity depends on how we store the frequency counts. The space required depends on the number of unique characters in the strings. In the worst case for English letters, this would be at most 26 characters. So O of 1, because again, like you got everyone saying, is just going through that. So a for Unicode characters, the number of unique keys could grow. Okay. So O of K. Oh, big O of K. And then for just single arrays, it's just O of 1. Okay. Oh, remember that if you do two linear time operations, it's technically still the same complexity as you did the one of the similar linear operation, because the time complexity measure growth as the limit approaches infinity. Remember that again. Remember that if you do two linear time operations, okay, yes, it's technically still the same complexity as you did the first, then did one of the same linear operation, because the complexity measures grow at the limit. Got you. Okay. Thanks, guys. Mm. So yeah, O of n plus O of n is still big O of n. Thanks. And for example, can you explain that? Yeah, big O of n squared is plus big O of n is still equal to big O of n squared. Duh, that's math. I'm stupid. I get it. Okay, never mind. You don't have to explain it. I was like, my brain is not working right now. Uh, I get it. Okay. Sorry, guys. All right, just so everyone can see everything. But it keeps going to. I need to type on this side. Because the chat just gets in the way. Or maybe I should move the. How about I do that? Yeah, the chat needs to move. Let's move this. Because now it's like kind of hard to read. Let's move this over here. Let's move my capture device over here. Boop. Yeah, that's way better. Jeez. All right, guys. If I'm being honest with y'all, I am hungry. So, and we did solve the problem. Okay. The whole point was to analyze and learn. So we understood. I documented what I knew. So yeah, we went through the problem, the input, the process, the output. I was like, we need a dictionary. We need a dictionary, and we need key value pairs. And then we have to like kind of like, sorry if my writing's fucking horrible, so apologize in advance. But so yeah, we did the S, S and T. We have to iterate through that, and then we have to increase the value depending on the occurrence of the key. Bro, I can't think right now. I'm hungry. Okay. And so then we return the equivalency of S and T. So, like for example, the input of, let's use 2 because I'm not about to do the anagram thing. So rat. So we have a key value pair of, so the key would be R, and then the value would be 1, and so on and so forth. So we have to go through the so I created the dictionary for the frequency of S and T. I'll just write that right now. So frequency of T, and then character, and the frequency of T. We get the get method, and then the character of and then we add 1, depending on how many it goes through. So yeah, we had a for loop through that. So for char in S, and then for char in T. Yeah. And yeah. Wait, let me just finish. I need to I'm like get sidetracked so quickly. This seems like you're over engineering this. Yeah, probably. I'm like, so yeah, understand the problem. We understand the constraints of the problem. What is the idea to solve this problem? Yeah, use the dictionary to compare the key value pairs, determine if the string length, if you have an array of n, if it is an anagram, then it must fulfill the property array for all values of a. Okay. Process 1, 2, yeah, so yeah. And then we figure out the complexity. Okay, guys. Again, thank you guys for watching. The stream was going to be longer. I was going to do 2 problems, but unfortunately I am really, really hungry, and I want to go eat. So again, thank you guys, everyone in the chat. I'm trying to pronounce names again. Fen Tom Cool, and then Emine Akachan. Why am I trying to see? And then did go. I don't know how to pronounce that, but thank you guys for coming to the chat and watching. I appreciate it, every single one of you. This is going to be every day at this point. Thanks, bro. Unfortunately, tomorrow I have I'm on a break. It's for religious reasons, so I won't be here tomorrow. But I'll start back on Sunday, so I just record myself every day. Yeah. Thank you guys for watching. If you guys are interested, you should like and subscribe. I think you guys already have, or if you're interested in this content, please, come back for more. I am new to this. I'm not like a master or whatever the fuck. I'm just starting new. That's like the description says. Like I know how to, like I know of coding and programming, but like I'm not like, fucking genius or anything like that. Just working my way up there. So hopefully the audio and the stream, everything was fine. Like bruh, what was I gonna say? Yeah, because like it took me so long to stream today because I had audio issues, and I was hearing like duplicates of the same audio, and then I figured it out. So yeah. If you want to figure out like my streaming stuff, like I talked about it earlier in the video. But yeah. Other than that, guys, thank you so much for watching. I stay tuned for Sunday stream, and yeah, thank you guys. Appreciate all y'all.